new learnings, right? A lot of good things, right? This is my second year. This is the second year for Commit Your Code, right? Last year I also spoke at here, and today we're going to be talking about predicting the future of equipment using ML.NET. My name is Ron Dagdag. I am an R&D engineering manager at 7-Eleven. I am also a Microsoft MVP. Been with a Microsoft MVP for almost 10 years now, right? AI, Windows development, Internet of Things, stuff that I really enjoy, mixed reality and all these different things. All right, let's get started. Of course, who among here are machine learning practitioners or have worked with machine learning? So we have a few people. So if there's some questions about machine learning, we have some that we can help out. C# developers. All right, you got more and more people. Yeah, all right, that's good. Thank you. Any maintenance personnel? Because we're talking about predicting, right? Prediction. Okay, so we have that. Fortune tellers. All right. Since we're talking about predicting the future, we're going to talk about fortune tellers. Of course, has anyone heard about this crystal gazing? Of course, that's what this crystal ball is. So about my crystal ball here. We'll see. We'll work on it later on. Okay, so our agenda today is we're going to talk about predictive maintenance, and then what is machine learning, ML.NET, model builder, and then we'll do a little bit of demo. Okay, what are the different evolutions of maintenance strategy? Yeah, most likely you've worked with, if you're more DevOps or SRE, or you maintain applications, you deploy it, and then of course something goes wrong, you become reactive to it, and then of course, as evolution goes, we have some more logging and all these different things. We become more preventative, right? And then condition-based. There's a certain threshold when you deploy it in the cloud, and then you have some monitoring. If there's a certain threshold that it meets, like let's say, it's not serving your customers, or in terms of the machinery, it started working or running, and then it didn't, it hit a certain threshold, and it sends an alert, right? And then, of course, now we're moving into this generation of predictive analytics, right? We're looking at the set of data, and from this set of data, we're trying to identify, is it going to fail or not, right? So those kind of things. And then in the future, and that's where we're kind of looking at in terms of the maintenance strategy, is more prescriptive, like be able to use a lot of these AI tools to be more prescriptive on terms of like, hey, how we can proactively fix and figure out the root cause. Today, we're going to talk about the predictive side of things. Okay, so just to visualize it, if you're working on a certain threshold, you'll go through that, and then if it's predictive maintenance, it'll be, with all the different data and trying to understand a certain set. So why would you want to do predictive maintenance? You predict before the equipment fails, or when the equipment fails, ways to take care of the machines, to keep it running smoothly. Of course, a lot of great things in terms of that. So, but before I do that, I want to talk about some machine learning concepts, because I've heard there's only a few people that may have been not familiar with machine learning and all these, right? So a lot of us here are programmers, right? Yes? So you've seen this, right? You had to have your input, and then you write the algorithm, and then you get the answers. Like if you have a calculator, right? We know how to calculate, add, subtract, multiply, divide, and of course you have your input, and then you have your answers, right? Machine learning, it's kind of flipped. You have your input, then you have your answers. You got a lot of examples of what the answers look like based from the input. And then what the goal of the machine is to learn the algorithm, right? To learn and produce what we call a model. So in machine learning world, programming on the right side, and then machine learning on the left side, right? And how are they connected to each other? In machine learning world, input is training data, right? You need lots and lots of training data, and you feed it into this training framework. ML.NET is also a training framework. And then you go through this algorithm, and that's what we usually call the model, right? GPT is a model. There's our foundation model. There's different kinds of model out there that you can use this. And then now, instead of the algorithm, you replace it with your model, and then you have your input, your model, and that's what we call inferencing side. So on the inferencing side, you need an inferencing runtime. ML.NET is also an inferencing runtime, and then it's a loop. So if there's anything that you want to take out of all these presentations, if you understand these, you know when to use when, right? When do you need to learn about creating the model, building the model, or using the model into your application? So of course, model development, there's a lot of stuff, right? So it depends on what you're trying to do, right? So if you're doing classification, you need tagging data in order to create your model. If you're doing object detection, computer vision, object tracking, action recognition, different set of data that you need. Tag data, training data, that's fully annotated in order to create the model. So that's where ML.NET comes into the picture, right? If you are a .NET developer and you want to learn about machine learning, being able to create applications that can be run online or offline, right? Or on the cloud or on the device, you can generate using ML.NET. It is a it is a training pipeline, so you can create the model, and also you can import existing model and convert it to Onyx. You can read Onyx models or TensorFlow models. And then, of course, it's cross-platform. It's Windows, Linux, and Mac OS. So ML.NET also includes AutoML. AutoML is something that accelerates in terms of training new data. So for here is an example. We're trying to figure out a taxi fare for one passenger from airport to downtown, right? So what does a machine learning engineer does, right? So it figures out based from the data, what is the input? So in this case, hey, there's car type, distance, passengers, and all that. Based from that data, it'll pick the right, training algorithm, right? So it picked this one, gradient boost, and then each algorithm will have all these parameters, kind of a way to tune it to be able to train a model, and then evaluate that model will give you a 30%, for example, accuracy rate, and then it goes to the next one. We'll figure out another one, and now it's better accuracy rate, it's 50%. And then you train another one, different set of features, different set of algorithms, different set of parameters, until you get to a certain point that say this model makes sense for this data set, right? You with me? Yes? So that's what ML.NET does, and also AutoML does. Based from that input, it would generate and find the best model. They would train the best model that you can use, and what is the optimized way to do that. It can also do explainability, which ones of your input has the higher importance as compared to the other one, and then you can start comparing it with all the other ones. So ML.NET has a called Model Builder. Model Builder is a UI tool that's inside Visual Studio to help, especially for the ones that no background in machine learning, but wants to learn the concepts of it, and also the same way integrate it into their application. So you can run it locally, you can train a machine learning project, or you can train it in Azure if you want to, but it always generates a custom machine learning model based from the training data. So 4 steps: you import the data, then you train the models, then based from that, you evaluate what does it look like, generate the code, integrate it to your application. Clear? Yes? Okay, so we'll do that. So of course, there's different types of problems that ML.NET and AutoML can help you. One is data classification, when you're trying to classify different machine needs. Value prediction, you can do forecasting, you can do recommendations, right? There's a lot of different things that you can do. Classifying images, and also object detection, right? So today, I'm going to focus on data classification because that's the easiest one that I can get everyone to try out. So classification looks like this, or this one is more regression, or this example, but my demo is going to be classification. So you remember, there's got to be features, and then at the end, you specify what label, what you're trying to predict. That's your label, and then of course your data set, and over each columns. If you're familiar with Excel, this looks familiar. As long as you have features and labels and columns and rows, yeah, you can do this. But okay, now we're on the demo. But before I do a demo, we're gonna do. It's always good to pray for the demo God just in case. But you know, our Wi-Fi is strong, 200K API. At the end, in open source we trust. Cool, clear? So let's get started. All right. So of course, since I have my what you call these, my crystal gaze, or I want to make sure that is my demo going to be good. So. Oh no, definitely not. I'm gonna try this again until I get to say yes or not. But my demo is gonna be great. Oh, points to no. So we'll know more. I prayed to the demo gods. I have my crystal ball. When the time is right, bro. This is the time. This timing is right. Okay, we'll do that. All right. So let's go to our Visual Studio. Okay. So if you're actually Visual Studio 2026, there's Insider Edition now. If you want to try it out, it's free. Try it out. It's something new. So if you're looking forward to this, but of course I saw it this morning. There's an update for the ML.NET Model Builder 2022 extension. So you can install this extension as part of your inside Visual Studio, right? And then this ML.NET Model Builder allows you to be able to say, I'm going to create a code. I can right-click on my solution. I can add, and then machine learning model. It adds that machine learning model capability. And I already did that. So it will ask you a few questions. A lot of us here, anyone here is visual learners. I like visual. I like seeing things because, and take me with the one step at a time, right? Because that's how I learn faster. So in this case, we're going to say data classification, right? And then we click next. We go to environment. Where am I going to run it? I'm going to run it in the cloud. I'm going to run it locally. In this case, I'm going to run it locally on my machine. Next, what is my set of data that I'm going to be providing here? I have the CSV file, and the CSV file looks like this, right? You have your different data set, but I have my label. The label is machine working or not, right? So that's just a Boolean, right? So what you do is you specify which column do you want to set the label. So in this case, machine failure column. So now I have the set of data from my CSV file. This is the set of data. I'm going to identify what type of data are they. Are they a feature or a label, right? So in this case, the machine failure is the label. I specify it is Boolean, and it's categorical. Let me specify that. And then I specify, okay, this one type is a string. Feature is single. That means it's like a number, right? Could be a floating point number or it could be a number, any number. And same way as for each one of these. And there are things that I ignore. I don't want to include this one. I don't want to include this one. I can ignore them. And also I specify them as categorical. So if I know it's string, but it's a category, so like product type or certain type, I can do that rather than treating it as a string itself. It would help us with the data set. And of course, validation data. Usually you split your data to like maybe 80-20. That means 80% training data and then 20% like to evaluate. But there's also a way you can do cross-validation. It requires a little bit more, but it splits the data into where it's not just 80-20, but it's like 5 iterations of splitting your data. So that makes it, the output better. Then we do some training. There's different types of trainers, and you can specify how long will it take. So you don't want to take forever in order to run this. You can say, depending on the number of set of data that you have, you can run it, 1 hour, 5 hours. It runs locally in your machine, but if you can also run the cloud. But give it a deadline, right? Just like any project out there, there's got to be some stopping point where we want to say, this is where we evaluate. Then there's also different optimization metrics. You can read more into this, what makes sense, and what makes, with your data set. There's different trainers that you can use. There's, parameters that you can set for the ML.NET trainer. And then you can say, click training, and it will run for 60 seconds. And then what it'll do is, let's see if we can run it. We have time. And look what it's doing. They're trying out different models in real time. Right now, there's like 10 models that are already tested. It took about 10 seconds, and it's the accuracy. It's picking up the accuracy. What it's doing right now, it's trying different types of models with different types of parameters, and then testing that model and getting the accuracy. So if you're doing this manually, you have to pick which model, parameter, train it with this data, evaluate, train, model, evaluate. But this one, it's doing it automatically. It's in automated fashion, and trying to figure out which one's best for your data set. Of course, right now it's like GBM binary, but there's different types of these models that it can be trained on. It's running it locally on my machine. So for the data set like these, you can run it locally. You can even try it out before you even, if you're doing proof of concept, before you even send it to your data scientist to analyze it, but it gives them a starting point. It's like, this is the best model that my data was tried with. But we can start there. We can do our testing there, right? We can evaluate. But after after some time, it gives you accuracy data, then you can evaluate it, right? So this is my input, and I can click predict, and there you go. It gives me the output, right? It gives me the data. What I do, I can try it out. So I can say, of course, I'm going to do a high number on toolware. Now it's telling me that it's 50% likelihood with this combination that it's going to be a failure, right? Based from the data set. So there's a lot more things that you can try, but it tells you like what are the likelihood of it failing with this set of parameters. So if you think about that, you have different parameters on your data set, different data that you look at on your machines, and then be able to. And then after you evaluate, and you think, hey, this is good enough, I can try this. Then I can create a console app based from the data that it built. So we're going to try this and say we're going to create a console app from scratch, or you can even make a web API, but just to make sure that everything runs locally in the simplest case. So it generated this console app. It actually created this MB config. This is the model that it's including in my application. It tells you how to connect with it. But if you look at program.cs, so let's do that and see if I can make this bigger. Control. Anyway, and if you can see that, it tells you right there, how do you use the model, right? I pass in this data from this ml1.model input, builds the model, and then you can just run it. Let's try that. Make sure it's good here. And click run. Okay, this is where. There you go. So it did run. The outcome cannot be predicted. Okay, so this one right here, it says predicted sentiment is false. So with this data, so now it is a console app. You can start incorporating, into your application, and then you can iterate from there, like which item that I need to include and which one I cannot. But you already have a machine learning model that can be integrated into your application, .NET application, and take it, demo it, and show it to the world, right? To show it to your boss, and that would, that would help you. All right, isn't it clear? Isn't it interesting, right? In a matter of minutes, what just happened, right? We trained a model, we incorporate it to a console app that is ready to go to be able to integrate it with our application. You can run it in the cloud. You can even integrate it to your application. Cool. So I have some screens there. So, of course, it's not the show. All right. So in summary, there's predictive maintenance, right? Predicting before any equipment fails. And then there's, we talked about machine learning. We talked about the difference between training and then the inferencing side. We talked about ML.NET, how does it affect .NET developers? What is it for .NET developers? We talked about AutoML to make it easy for us. We talked about ML Model Builder in order to generate custom models inside Visual Studio. One thing I didn't talk about is you can integrate it also to your MAUI apps, to Android, iOS. So it's cross-platform right there. And it allows you to be able to do that. By the way, my name is Ron Dagdag. And if you can connect me on LinkedIn, feel free to connect me. There's a QR code right there. And if you can leave me a review or provide feedback, the bottom is the connection to our agenda so that you can provide feedback. I really appreciate that. Do you have any questions for me?
It's possible to add any set of layers and create functions into the model?
Yes. So it iterates that. Depends on the model that you're trying. These are traditional models. It's not like GPT or it's not the large language model. These are traditional models that you can create for data classification. Yes, it does that. Yeah. Any other questions? Yes, sir.
Yeah. So what's kind of like the main difference between this and like using like an MCP server that has access to like whatever data set you have?
Right. So MCP server, it's more of like kind of API and how you would connect to a large language model that you can feed into a large language model. This one is for traditional machine learning models, like I was showing the data classification, computer vision. There's a lot of different models that's simple enough that you can integrate it, that does not need a large language model in order to be effective, right? Because it adds complications. Sometimes the simplest thing can fix the job, and that's what you want to look for as an engineer, right? Overcomplicating things, and maybe it's one of these is what you need, right? Maybe it's one of these: classification, object detection, action recognition, which is what is important. Any other questions? Yes, sir.
Well, that demo was the smoothest demo I've seen all.
Thank you. Right. That's good. What are the different issues?
Yeah.
I mean, training data, right? Yeah. Do you have enough training data? That's what you need to. Any machine learning model, right? If you want it to be effective, how much data you have? But you can connect it to SQL Server. You have an CSV. Try it out there, right? Start with something, right? Start with integrating this. And the interesting part of this is it can be incorporated into your application. You can revise it, right? And it doesn't require us to, hey, I need a data scientist. This one does not require us a data scientist. If you know how to evaluate, and if it's good enough, right? It's good enough, right? And what does the business need? Sometimes it's good enough. It doesn't have to be perfect. And that's what we're here for, right? Yes, sir. Large data, you can run large data sets. Of course, there's limitation. You can run it locally on your machine and all these, of course, complication, right? So there's ways on, I don't know if I have this here, but you can run. So for example, if you have this much data set, right? You have 1 gigabyte of data, most likely it'll take you about 3 hours to do some training, right? And what makes sense, right? And sometimes if it's a computer vision task, you might want to, do it in the cloud, right? So like, for example, there's instances where you can run it local GPU, or it makes sense to run it in Azure and all these. So there's different, of course, parameters, and it depends on what you're trying to do. So. How do you capture data from the equipment?
Yeah, what sort of technologies would you recommend some of the things you want to explore that?
That's when it comes to IoT, right? So how do you connect IoT to send data to the cloud and then collect that information? And if you were in the previous talk, Azure Functions is another way to connect to your IoT and process that data to incorporate it to your database, right? So that's one way. You got streaming data or however you get that data, or you can just do a batch, right? I remember I used to work for an elevator company. Okay, elevators, they're not always connected to the cloud. So what do? They upload the CSV file. Whatever that machine log is, whatever telemetry data you have there, then you process it in the back end, do all this stuff, right? So, and then you can have a model specifically for a certain elevator. Right, you can incorporate AutoML into your CI/CD builds and those kind of things, right? Any other questions for me? Cool. All right, thank you very much, everyone. Yep, thank you.